Hi and welcome to the first video. We're going to kind of look at states of matter. Most of us are pretty familiar with the three different states of matter. So we've got solids that we typically represent as an S, and we've got liquids that we typically represent with an L, and we've got gases that we typically represent with a G. So these are the three common states of matter, at least here on the Earth. And if we look at what makes a solid and a liquid and a gas, so in a solid, the particles are typically packed in a very irregular kind of array like so. And in a liquid, things are a little more higgledy-piggledy. I mean, they're touching each other. We still refer to it as a condensed phase, but they're not so much order. And in the gas phase, essentially the molecules or the particles are extremely far apart, and they're moving quite rapidly. So in the solid phase, these guys might be sort of vibrating, but pretty much staying in place. In the liquid phase, these guys might be kind of passing over each other, so one atom or one molecule is not going to stay put. And in the gas phase, these guys are just chaotically, randomly moving in different directions with a kinetic energy proportional to the absolute temperature. We can convert from one phase to the other, so we know that we can add heat to go from the solid to the liquid phase. We can add heat to go from the liquid to the gas phase, and we can add heat to go sometimes directly from the solid to the gas phase. And if you remember these transformations, so solid to liquid, this is called melting or fusion. Liquid to gas is called vaporization or evaporation. Solid to gas is called sublimation. So you should make sure you have those names written down in your notes, and I'll just quickly scratch them above the arrows, like so. And we can also go in the opposite direction, so we can remove heat and change a liquid into a solid, and that is called freezing. And we can remove heat and take a gas into a liquid, and that is called condensation. And we can take heat and remove it from a gas and turn it into a solid, and that's called deposition, because we literally end up depositing a layer of solid. And we're probably quite familiar with these, I'm guessing. I'm guessing you've probably seen these before. But what we're going to go ahead and do now is we're going to try and explain why this happens. So why is things sometimes a solid and sometimes a liquid and sometimes a gas? And why does sometimes it takes more energy to melt something? For instance, it takes a lot more energy to melt ice than it does to melt, say, solid benzene. So why is this a case? And what we'll see is that, one actual fact, what the answer is to these questions is intermolecular forces. In a solid, there are relatively strong attractions between the particles. And in a liquid, they are sort of moderate attractions. Whereas in a gas, there are quite sort of weak attractions. Now, when I say strong, moderate, or weak, it may actually be exactly strong, moderate, or weak, or it might be strong relative to thermal energy. So at very low temperatures, there's not a lot of energy coming from the environment, so an attraction might be strong compared to the environment that it's in. And as we heat up a system, right, we increase the temperature, the thermal energy is much higher, and so we might end up with a situation where we've got a liquid where the attractions between the molecules are moderate compared to thermal energy. And as we keep increasing the temperature, then what we'll find is that the environment itself has a lot of energy, the thermal bath of the surroundings has a lot of energy, and so we might have a gas when the attractions between the particles are much weaker than that of the thermal energy of the surroundings. Let me show you a quick application I have, and then we'll move on to discuss what the interactions are themselves.